there aren't any that are just E up there. I want to know which of these are isotopes? Which of these are isotopes?
The second one before.
These? These? What do we have to look for to tell if they're isotopes? If they have the same number of protons, and which number is protons?
The bottom.
The bottom number. So this one has an atomic number of 12, and that one has an atomic number of 12, but they have different masses, 22 and 23. A lot of times people look at this and they say, oh, there's two answers. I bet that's going to be a choice also. These both say 22, these both say 23. Aren't they isotopes? Not of each other, because we have to have something with the same number of protons. Protons make the element what it is. Neutrons tell us how heavy it is, if it's overweight or not, and electrons tell us how they behave. Alrighty, 21. Define or describe the law of multiple proportions, definite proportions, and conservation of mass. This goes back to the fasteners and ring lab. You're going to want to go over that carefully. I'm going to hand those back tomorrow. I'm still waiting for late work turned in from somebody. Okay, and today is the last day for that. So you'll get your fastener and ring back. We were looking at fasteners and rings representing different kinds of atoms, and we were looking at their mass proportions and how they compare to each other, and we got some consistency there. Everybody in the class was getting the same proportion, and that tells us something about the law of conservation of mass. Okay, so what can you tell me about any two samples of sodium chloride? If I have a bowl full of sodium chloride and a test tube full of sodium chloride, what is something that is similar in terms of the law of conservation of mass, or law of definite proportions? Density is going to be similar. Okay, if we have a small test tube full versus a bowl full, we're going to have a different mass, right? But think about what's in here. Proportionally, they're going to be the same. There'd be the same proportion by mass, grams of sodium to chlorine, no matter what size sample we have. Just like there was with FSR, when we all got a proportion that was about 0.273 of one element to the other. Okay, so sodium is always going to, or sodium chloride is always going to be a certain percent sodium, and it's always going to be a certain percent chlorine. 22, oh, Thomson, we need to know the guys now. Explain how Thomson's experiment determined the charge of an electron. What piece of equipment did Thomson use? JJ.
Oh,
We loved watching it. We spent hours and hours. A what? A what? A cathode ray tube, which is not flat screen TV. Okay? Cathode ray tube experiment. And what did he see when he zapped that? Yes, and what did they look like? Like a glowing green beam of light. So he had his cathode ray tube, and it had a stand and things attached. There's a lot more to it than my drawing. But he saw this glowing green beam of light going from one end to the other when this was attached to a voltage source. And he realized that that glowing green beam of light could be affected by positively charged or negatively charged plates, and it would bend toward the positive side. So he figured that the particles inside must have a negative charge. And he's the one that gave us the name electron. You with me? Okay. And 24. Nope, did I miss one? 23. Also about Thomson's experiment. And this time we're talking about the identity of the electron. So I kind of covered that. I covered both questions with the description here. So that was 22 and 23. In 24, we're looking at Rutherford's gold foil experiment. What did Rutherford's experiment do? Actually, what happened during Rutherford's experiment?
The particles passed.
The particles passed through what?
Gold.
Gold foil. So he had a piece of gold foil, which is going to be orange for us because I don't have a gold marker. And he shot alpha particles through it. And they went whizzing through here. And what happened to them? Some of them deflected. Because what? They hit the nucleus. So at the atomic level, we've seen this picture in the videos that we're watching on Moodle every day because we are just awesome and we always go to Moodle and do our homework. And we found that there is a nucleus and those alpha particles, because the rest of the atom is empty space, most of those alpha particles were going right through, but sometimes they would hit or come near the nucleus and bounce off. What did that tell Rutherford about the nucleus? It was very dense, almost solid. Probably we could consider it to be solid. What kind of charge? Positively charged. Are you sure? Are you positive? Yes. Positively charged nucleus, because the alpha particles are positive. So positively charged things shot at other positively charged things are going to repel. If they had opposite charges, then they just stick together. Awesome. So that is test-ins up to number 24, and the next class will continue with 25.